Hello, everyone. Thanks, Quentin. Like Quentin said, my name is Vlad Vlaschanu. I work for Amazon Web Services, and I work with customers here in Southern California, helping them design and run effective solutions on top of the AWS platform. Today's webinar is focused on running Microsoft SQL Server on AWS. Just to give you an idea of kind of how the webinar will run, we'll spend the first 15 minutes or so providing an introduction of the options and capabilities of the platform for deploying SQL Server, followed by a walkthrough of a hands-on lab. Now, later today, after this webinar concludes, you will have the opportunity to do the lab as well. You will receive a link over email sometime today, where you can log in and start your own lab. A recording of this webinar will also be available shortly. As you may already know, AWS has two services that can be leveraged to run Microsoft SQL Server. Amazon RDS, which stands for Relational Database Service, is a fully managed service that takes some of the administrative tasks off your shoulders, like backups, patching, or configuration management. This allows you to focus on more valuable activities like optimizing schemas and designing your schemas, or doing query optimization and enhancing the performance of your own applications. On the other hand, Amazon EC2, which stands for Elastic Compute Cloud, lets you run SQL Server where you have full control of the instance. You trade off some of the management aspects as more of the administrative tasks fall under your area of responsibility. In either case, you can bring your own license, we call that BYOL, or you can buy your licenses from AWS, we call that license included. For example, when you launch an Amazon EC2 instance, you can choose one of our AMIs, our Amazon Machine Images, that already has Windows Server and SQL Server pre-installed. In that case, your hourly instance cost includes the software licenses as well. Now, you should evaluate the two options in the context of your specific workload. You decide which model fits best with your application requirements, with your organizational needs, and available resources. Here are a couple of comparative highlights. The same editions are available for both EC2 and RDS. You would use the same native tools you are familiar with to interact and manage both. Think tools like SQL Server Management Studio or the SQL command line. You can use SQL Server database instances running on both EC2 and RDS as sources and targets for data in SQL Server reporting services, or SSRS, or SSAS, or SSIS integration services. Although those services cannot be hosted on the RDS instance itself. Authentication and encryption capabilities are similar on both platforms. In fact, you can use encrypted block storage on AWS with every edition of SQL Server. You are not limited to deploying TD or transparent data encryption. Only Amazon EC2 will give you full control of the instance. And although it is the same SQL Server database engine that's running in RDS as well, it is a managed service, and you would have no ability to access the file system directly or RDP into that RDS instance, or leverage the sysadmin role. On the other hand, RDS provides automated backups with point-in-time restore, consistent configuration management via parameter and option groups, and automated patching. For high availability, you would manage your own always-on availability group clusters in EC2, whereas RDS provides a fully managed solution. So focusing briefly on running SQL Server on EC2, here are a few highlights to keep in mind. As I already mentioned, you will have full control over the instance, and you will have to manage your own backups, patching, or maintenance. You can also deploy legacy versions of SQL Server, versions such as 2005 or 2008 on EC2. And you can also deploy SQL Server on dedicated hosts, where you can bring per socket or per core licenses that aren't part of Microsoft Software Assurance licensing, with license mobility. You can also leverage instant storage, which are direct attached drives, typically SSD-based, to deploy really high I/O intensive clusters that exceed the capabilities of network block storage provided by Elastic Block Storage by Amazon's AWS service. For example, instance families such as the X1, I2, or I3. The last point is really key. You can deploy high availability effectively across multiple data centers, protecting you not only from instance level outages, but entire data center level outages. In AWS, having multiple availability zones is a game changer. An AWS region, which is a geographic boundary, is comprised of multiple availability zones, which in turn are backed by multiple physical data centers. Availability zones are close enough to facilitate latencies, usually between 1 and 2 milliseconds, but are on different floodplains, power grids, and so on for added resiliency. In a traditional data centers, most organizations will not even attempt to set up synchronous commit between data centers, simply due to the latency problem. But in AWS, synchronous commit across multiple availability zones isn't only practical, it's the norm. This means you can do automatic failover across data centers. How or when could you have done that before? When you deploy offsite synchronous replication with AWS, you don't have to build your own infrastructure, wiring, power, racking, and stacking. And synchronous replication between availability zones is, I think, very distinct from what other vendors are able to offer between their own data centers. So let's take this a step even further. This diagram shows a region, a multi-region, a multi-availability zone design for a SQL Server always on. It's definitely not something that's required, and most organizations won't require this level of resiliency. But still, this option is available. Automatic failover occurs between availability zones within the primary region, but there's also an asynchronous commit going over a VPN connection between different regions, allowing you to do a manual failover at that level to an entirely different geographic region should the need for that arise. Now, an architecture across two availability zones is mostly for high availability. But if you are concerned about the risk of an entire region becoming unavailable, here are two options you have for DR. The first option reduces your recovery time objective and recovery point objective, the RTO and RPO, but running a hot standby, like we illustrated in a previous slide, would just result in added costs. A lower cost option is what I like to call just-in-time DR. This means you have a standby environment that's provisioned using a CloudFormation template. CloudFormation is our infrastructure automation tool that allows you to spin up complex infrastructures. And you simply have that template ready to spin up your entire infrastructure in another availability zone. And then you restore SQL backups from S3. Now, of course, this will take longer, perhaps several minutes or even a whole day. And you may still have a risk of data loss for a small amount of your data, since you're relying on backups and transaction logs. However, depending on how you manage those transaction logs, that could considerably be a more effective, more cost-effective DR solution. Now here's also some good news. If your secondary instance is truly passive, and if you have Microsoft Software Assurance and BYOL and bring your own license, you can cut your SQL Server licensing costs in half. License mobility is a benefit of Microsoft Software Assurance. Now do note that your secondary instance, has to be truly passive, and it cannot be used as a read replica. There are many benefits to buying license-included SQL Server from AWS, but this really isn't one of them. This passive license benefit only applies to bringing your own license. Now, on the other hand, if your SQL Server workloads aren't running 24/7, for example, if you use SQL Server for ETL processes that are batched daily, using our license-included option might be more cost-effective. You can spin up the SQL Server instances only when you need them and only pay for the licenses while you're running that workload. Now let's focus briefly on RDS. Like I mentioned already, it is a managed service and comes with several built-in capabilities. You can deploy a highly available cluster comprised of a principal server and a passive secondary in a different availability zone. Simply choose the multi-AZ option at deployment time. Failover is automated. You simply connect your applications or your SQL clients to a DNS endpoint instead of an IP address. And we manage that DNS endpoint on your behalf, and we change the DNS entry to reflect the IP address of the principal server in the event of an outage. So if there is an outage of the principal server, we simply do a failover to the secondary and change and update the DNS entry. All you have to do is ensure that your application has connection retry logic. Once your application detects that the connection has been broken, it attempts to reconnect until it goes through to the new primary server. All of this process with appropriate connection retry logic is designed to take roughly about a minute. Another interesting feature is native backup and restore to and from Amazon S3. Amazon S3 is our object store. You designate an S3 bucket for use with your RDS instance, and you refer to it when exporting or importing backups. Now, similarly with running SQL Server on Amazon EC2, you can bring your own license to RDS as well. But to bring your own license to RDS, you have to submit a license mobility form to Microsoft to verify your licenses. Microsoft will email you and AWS once the verification is complete. Now, you can actually deploy your application up to 10 days before submitting the form. When you launch your RDS instance, you simply choose BYOL instead of license included in the appropriate licensing dropdown. Okay, so this last slide is really a preview of the demo on what we'll be doing in the lab in a few minutes. There are 4 key aspects to the lab. First, when you click Start Lab, the lab environment will run CloudFormation behind the scenes and automatically provision all the resources needed for the lab. It will automatically create an EC2 instance and an RDS instance along with all the other dependent resources. Now, the EC2 instance will be used as a workstation to mimic an on-premise instance of SQL Server, just like any sort of workstation you would normally be using to connect and interact with SQL Server. The name designated by the lab environment, QL created RDS, just means that Quick Labs, our lab provider, creates that instance on your behalf. Now, second, at the beginning of the lab, you will launch your own RDS instance. We'll call that RDS test. This will give you an idea of the provisioning steps involved in launching an RDS SQL Server database instance. but it takes about 15 to 20 minutes for an RDS instance to spin up, which, if you really think about it, and all the steps that are involved in terms of bootstrapping, configuring, and installing SQL Server software, that's actually quite remarkable. To avoid waiting on that instance, you'll be doing the rest of the lab with the QL created instance. In other words, after you launch RDS test, we'll just simply ignore it. Third, you're going to use PowerShell to download the AdventureWorks sample database from Microsoft and create it on the SQL workstation. And the last step, you will export the AdventureWorks database from your EC2 instance to your RDS instance. That demonstrates one of the ways to migrate a database to the cloud. To connect to the AdventureWorks database on the EC2 instance, you will use the local administrator account using Windows authentication. RDS also supports Windows authentication, but we're not going to be setting up an Active Directory in this lab, so you'll use SQL authentication instead. Now finally, notice that the database name is called sample on the RDS instance. All right, so before we start, just kind of wanted to remind you during the demo, you don't need to do anything but watch. And if you have any questions, please write them down into the Q&A window. I'll show you a few things that will help you with the lab. And as soon as the demo is over, once you get that email invitation sometime today, you'll be able to also do that lab on your own. So I'm going to switch over from the presentation view to my web browser screen. And what I have here open is the lab environment with the link to the introduction to Amazon Relational Database Service, RDS SQL Server Lab. The link that you will be receiving later today will also contain the necessary instructions for you to get here. And like Quentin mentioned at the beginning, you will have to have an account with QuickLabs, our lab provider. Now, take a few minutes to kind of familiarize yourself with the interface here. So we'll have the main panel on the right side where all the lab guide is situated and all the step-by-step instructions are available. You can scroll down through the lab guide and you'll see the instructions, a brief introduction, as well as the steps that you will have to take to complete the lab. Right in the top right corner of the interface, at the top here, there's a button called Start Lab. Once you click that button, it will start initializing the lab environment, and the countdown clock, which is here, indicates 50 minutes, will start decrementing. On the left side, once the lab environment is initialized, you will see connection information and some of the parameters as well as passwords that you can use to connect to your EC2 instance to interact with our management console. So I'm going to go ahead and click Start Lab. Now, it may take a minute or so to initialize the lab, to start initializing the lab environment, and like I mentioned before, creating some of those resources can take 15 to 20 minutes more. In the meantime, we'll spend the time walking through some of the other preparation steps. All right, so the lab environment just started initializing, and I have a button here that now can end the lab and a progress bar right across the top indicating the progress in provisioning all the necessary resources for the lab environment. On the right here, I have a button. On the left side here, I have a button to open the AWS Management Console. And I can use this to simply click and jump over to the AWS Management Console without having to actually input any additional credentials. Now, just as a reminder, this console that opens up is going to be in a dedicated sandbox. It's not going to be in your personal account. I'm going to click Open Console, and the AWS Management Console will be initialized. Now, since our console layout has changed a little bit over time, I want to spend a few seconds here walking you through how the interface looks like on AWS and how our interface works. Across the top, on the dark gray background, you'll see a quick access toolbar. On the left side, you'll see the AWS, a little kind of box logo that will take you to the home page of the console. Next to it, there's a services drop-down. So because the number of services that we have has grown over time to over 90 services, it becomes a little bit hard to actually fit them all on the same screen. So we have a couple of capabilities, and we list them in categories that you can scroll to the categories and go to the right service. You can also use the little finder window to type in the service that you would like to go to. And on the left side here, it will maintain a history of the most recently accessed services. Now, the list that shows up on that left side will be different for you than from any other lab participants or from what you see here on my screen. It is based on your access patterns and what services you have accessed in the past. It might be completely blank, especially in the lab environment, if you haven't accessed any services before. There's also an ability for you to add shortcuts to the different services. You can see those little colored icons across the top of my interface here. You can do that in your own personal account as well. And recently visited services also show up here on the main screen, as well as a link to expand the section with all our services. So the first thing we want to do is spin up an RDS instance. So I'm going to toggle back to our lab guide here, switch over to the other window, and scroll down to begin our lab and our walkthrough of the lab. So first thing we're going to be doing is creating an RDS SQL Server instance. We'll move to the RDS Management Console, launch the instance, and use the parameters specified over here to launch the instance. So we'll choose the licensing included model, the right database class, configure the right connection information, and move on to the next step. Going back to the AWS Management Console, I'm going to go to the list of all services, go to the database heading, and click on RDS. The RDS Management Console will load. And right here at the bottom, I have a button that says Launch a DB Instance. I'm going to click this blue button here. And I have several options depending on the database engine, with the database engines that are available on the RDS platform. I'm going to navigate down to SQL Server, the SQL Server tab, and choose SQL Server Standard Edition. You notice here that there are several editions available for SQL Server. We'll pick SQL Server Standard. Now, the first prompt you'll see here is asking what sort of setting this database will be used. Since we're running a lab, I'll pick Dev and Test. Regardless of the option you pick here, you can always change it later. I'm going to click Next, and now I have the opportunity to provide the specifications of my database instance. I'll be choosing license included for the model. I'll be choosing SQL Server 2016. I'll use DB4 large for the database instance class. You can also configure a time zone, and some applications might require local time zone. Typically, the default in AWS will use UTC as the standard time zone, but you can change that to any time zone that matches your workload's expectation. I'm not going to deploy a multi-AZ instance. I'm gonna leave all the other settings as default. And now I'm going to toggle over to the lab guide to get the right settings for the instance. So we'll name the database RDS test and use the master username of student and master password of pass.123. Now I know that password is not very secure, but bear with me. This is a lab after all. All right. I will click next step. And now I get to configure network security aspects of my database instance. I'm going to leave the VPC as default. I do not want my instance to be publicly accessible from the internet or get a public IP address. So I'm going to choose no here. And according to the lab guide, I need to pick the security group that has RDS QLS in the name. So I'm going to look at this here, and there's one that starts with RDS QLS here right at the bottom of the drop-down list. We will not be connecting Microsoft SQL Server to an Active Directory environment, so we can skip this red warning here that says that we're not authorized to access a directory. And we are going to leave all the other settings with the defaults. So you can configure additional options for your database. You can change the port. You can have custom parameters that you apply to that database. You can choose to encrypt the database. And you can choose to configure the backup and maintenance windows for your application, as well as whether you like enhanced monitoring, which provides additional granularity for your database instance monitoring optionally. We'll leave the defaults here just because this is a lab, but if you're launching a production instance, you would want to configure the backup window and backup retention period to something that matches your application's needs and your resiliency needs. The backup window should be configured to a time of day that your database server has less load. And from a maintenance perspective, you would also want to configure a custom maintenance window that reflects the day and time of the week where we can apply maintenance patches to that instance if needed. You can also choose whether you want RDS to automatically upgrade your SQL Server database instance whenever minor version upgrades are available, or whether you would like to retain that level of control and do it yourself. So when you choose no in that auto minor version upgrade dropdown. For now, we'll leave everything with defaults. And I simply click Launch Database Instance. And our instance will start being provisioned. Now we've finished the first step here, so next step will change our security configuration for the security group, which is effectively a stateful firewall around your database instance. Because we're launching our own instance, we'll want to make sure that we can actually access that instance. So going back to the management console, I'll click View Your Database Instances. Now you'll see that there's two of them here. The one that we just named RDS test is being created. The one that's been created automatically by the lab is in a stage called backing up, still being initialized as well. And I'm going to go back here in the top left corner to services, and I'm going to navigate to networking and content delivery and click on VPC. This is our virtual private cloud. This is our networking infrastructure that management service. So you can configure your own effectively your own portion of the AWS cloud with your own private IP addressing, and then deploy resources in that within that fabric. We already have one VPC that's available, that's been created on all of these resources, have been already created on our behalf by the Quick Labs environment. So I'm going to go down on the left side, on the little menu on the left side, under the security section, to security groups. And now I'm going to toggle back to the lab guide view to look at the next several steps. So once we are at the security groups, we're supposed to find the security group that contains RDS QLS in the name. And then we're supposed to go to the inbound rules section of that security group configuration and change the MS SQL port 1433 rule to allow traffic from any source. So going back to the VPC management console, the RDS QLS security group is available here. It's the one on the bottom in my screen. I can check that box, and you'll see that on the bottom it pre-populates with the details. There's a detail pane that pre-populates with all the information for that security group. I'll make this window a little bit bigger by just dragging it up. And I'm going to go to the tab called Inbound Rules. You'll see that there's a single entry here, one for Microsoft SQL Server, port 1433. And it has a different source, a different security groups as a source for authorizing traffic. So I'm going to change that value. I'm going to hit edit and change that value to 0.0.0.0/0, which effectively authorizes any source to connect to it. Now you'll recall that I chose not to make that instance public whenever I deployed my RDS instance. So really this rule will only have effect to any sort of resources that are launched within that VPC or accessible through that VPC. So I wouldn't directly, just because I set that value to 0.00, would be able to directly connect to it from the internet unless I would have made that instance publicly accessible as well. I'm going to save the configuration. And at this point, we have completed the security group section as well. So the next thing we want to do is connect to our EC2 workstation instance that has been provisioned on our behalf by Quick Labs. So we're going to go to a different service, to EC2. We're going to navigate to instances. We're going to find out what the public DNS name of that instance is, and then leverage remote desktop to connect to that instance. So switching over to our AWS Management Console, I'm going to go to Services. Under Compute, I have an entry for EC2, which is our Elastic Compute Cloud. I'll click on that and load the EC2 console. Now, similarly to all the other consoles, you'll see that on the left side, there's a menu of options available. I'm going to go under the Instances heading and click on Instances. This will list all of the different instances that we have in this account running. You can ignore safely this notification here on the right side. Usually when it's a new environment, AWS will notify if there's major type of changes in the way the service works. This refers to the way how we identify instances. It will not impact our lab, so I can safely close this. And what I see here is one instance, an M4 large type instance with the name Quick Labs, starting with Quick Labs. Similarly to the security group screen, when I select this instance, on the bottom there's a detailed pane. I'm going to make this a little bit bigger. I will see all sorts of parameters and configurations that we have that were applied to this particular instance. The one we're looking for is public DNS IPv4. This gives us a DNS name that's publicly accessible that belongs to that EC2 instance. I'm going to copy this value, and I'm going to add this value to my remote desktop configuration. Now I'm running a Mac here, so your interface might be a little bit different for the Microsoft Remote Desktop client. In my case here, I have to open a new connection. Simply paste the name of this to name the connection, and paste the name of the PC, and add credentials for my connection. For the username, we'll use administrator. And the password, if you're launching the instance yourself in your own account, this password will be something that gets encrypted and gets configured automatically at boot time. You will choose an EC2 key pair, a set of keys that you use to encrypt that we use to encrypt the password, and you hold the other side of that pair of keys where you can use to decrypt the password. Now, the reason for that is because there's a shared responsibility model in running on AWS, which means we don't have any sort of access to the contents of your virtual machines or EC2 instances running on EC2. You alone hold the administrator credentials for those instances. And we have no way of retrieving those outside of, obviously, outside of you being able to retain the private key for your encryption key and being able to decrypt the password itself. Now, Quick Labs does that all for us, and you'll see the password available here on the left side, right under the button that says Open Console. There's a password. Technical difficulties. So I was configuring the remote desktop client. I have the configuration settings already here. I'm gonna just use full screen just to make things a little bit easier to see. And now I'm ready to connect to that RDS instance. You'll see a certificate validation error here. This is normal. You can just hit continue. And it may take a few seconds for the EC2 instance to become available. We are logging into that EC2 instance for the first time, so usually Windows has to run a couple of background processes. In the meantime, I'm going to switch back to the Quick Labs guide to see what some of the next steps are. So now that we're connecting to the remote desktop instance, what we'll be doing is effectively creating the AdventureWorks database on that Amazon EC2 instance. Now you may be wondering, what we've actually launched, what Quick Labs launched on our behalf, is an actual instance with SQL Server on it. So we can actually download that database from Microsoft and simply import it into the local version of SQL Server running on that EC2 instance. And we'll be using several tools to interact with that database. We'll be using PowerShell ISE to download the database, and we'll use SQL Server Management Studio to check that the database was imported successfully. I'm going to check again and see what the status of our EC2 instance is, and it looks like it's still initializing. Now, what we're effectively going to do is run a PowerShell script that downloads the data from Microsoft, and then another PowerShell script that invokes the SQL command line to create that database. And then we will be using SQL Server Management Studio to connect to that database and check that the data was loaded. Looks like it's still taking a few minutes to load. depending on the size and the configuration of your instance, the time it takes for the initial login can vary, right? Because of the different bootstrapping process. In this case, I want to remind you that we do have SQL Server running behind the scenes as well. So that may be contributed to an added delay to initializing the EC2 instance. All right. Looks like this is taking a little bit longer than anticipated. Do bear with us for a few minutes. This may take a little bit of time. In the meantime, if there are any questions, let me check real quick if there's any questions that our moderators would like us to address on the in the QA window. And it doesn't look like there's anything there yet. All right, so there's a question from Billy here that is actually quite interesting. We mentioned earlier that performance could potentially be tuned better if using EC2 rather than RDS, and he's asking whether isn't the performance based on the design of the data tables more so than the properties of the instance itself. And you would have control over the data table design in both environments. From a data and schema design perspective, that's certainly true. However, there's a couple of different things that are different between EC2 and RDS. One of them I've already mentioned. EC2 has access to direct attached storage, which could potentially get you higher performance levels at the very top end of the performance needs for SQL Server. Direct attached storage is not available in RDS right now. So from an I/O perspective, you can certainly get a lot more I/O throughput with direct attached storage. The other aspect is you do have access to the EC2 instance and to the operating system, to the SQL Server engine. And there may be configuration flags that are available that can be tuned for SQL Server better in EC2, and more of them in EC2 than there would be in RDS. So that would also impact the potential performance that you can be getting. The third aspect of performance management, there is the infrastructure performance as far as the types of instance types that you have access to. RDS has a more limited amount of instance types that are available compared to EC2. So that can also impact the types of configurations that you can provision. I'm going to check again on this particular environment to see what's happening, as it does look like the connection hasn't been established properly. All right, so now it's working. Apologies for the delay. And it looks like it's at the same screen here, still waiting for the initialization to complete. All right, so it looks like it's working right now. It does not normally take quite this long to log into an EC2 instance running Windows for the first time. This is specific based on, there's also some bootstrapping actions that are performed for the Quick Labs environment, as well as the fact that we're having SQL Server running on that instance. That should be coming up in a second here. Let's address a couple of other questions in the meantime. So Chip is asking whether there are any replication options for SQL Express RDS. So multi-AZ is only available for the standard edition and enterprise edition. Multi-AZ relies on SQL Server database mirroring behind the scenes to enable replication from the principal server to the secondary server. There's also witness there that I know we don't necessarily talk about it, but it's available to kind of ensure a quorum system. But database mirroring is not available for SQL Express as a database, as a SQL Server edition. So unfortunately, for SQL Express, there are no ongoing replication options in the RDS environment. All right, so our EC2 instance is now up and running. I'm going to go ahead and navigate and find PowerShell. And it's still loading some of the OS components here. All right. I'm going to navigate to my application. I'm going to go to Windows PowerShell ISE, start up that program. And while it's starting, I'm going to toggle back to the guide and simply copy the PowerShell, the first PowerShell script that we want to use. All right, I'm going to paste the PowerShell script and run it using this little green arrow over here. So now we've downloaded the AdventureWorks database. I'm going to go to Windows File Explorer and go unzip that archive. I'm going to go to the local disk. We've saved it in users public DB in the folder called dbdump, and I'm going to simply right-click on it, extract all, accept all the defaults, and run the extract script. Now I have here a database file and a log file. I can close my Windows Explorer window. I'm going to go back to our lab guide and, sorry, that was the wrong window, and copy the second script. And go back to my Microsoft desktop. I'm going to wipe away this first script that I have here and paste the second one in, and making sure that the path of the files is correct. So I have users public dbdump and then the name of the database for both the LDF and the MDF files. And I'm going to again run that second script. So at this point, SQL command will run and simply import the database. To make sure that that's happening, we're going to go to SQL Server Management Studio. And open up that application, which may also take a little bit to start up for the first time. a little bit longer. Let's try this again. There we go. I can close PowerShell in the meantime. We will no longer need that. We will not need to save the file. And now we're waiting for SQL Server Management Studio to start. All right, while this is happening, let's pick another question from the list. Okay, so Amir asked whether SQL Server is installed by default on EC2 instances. So the answer to that question is no. In the EC2 environment, so we have what we call Amazon machine images. So these machine images are essentially templates that you use to launch server, provision your own EC2 instances, provision your own VMs based on. Depending on which Amazon machine image you start with, you will have whatever the configuration of that machine image was built with. So we have machine images that have simply a baseline Windows environment. We have machine images for Linux environments. We also have machine images with Windows and SQL Server. So if you pick an AMI that has Windows and SQL Server, then SQL Server would be installed on that instance automatically. You will also be charged for the SQL Server license. If you pick an instance that only has Windows on it, if you pick an AMI with only Windows on it, then SQL Server would not be installed by default. You would have to do that yourself. Looks like Management Studio is up and running. We'll use Windows authentication to connect to the local server. So let me try this again. Looks like the database server had I doubled up, so I will use Windows authentication to connect to the database engine. And once it's loaded, we will see the AdventureWorks database available here, and we can browse the tables for it. All right, so moving on to the next step of our lab. The next step is accessing the RDS instance using Microsoft SQL Server Management Studio. So we'll go back to the AWS Management Console and navigate back to the RDS console where we initially created that RDS test instance. I already have it in the history since I've used it, so I'm going to just click on the link in the history, and I'm going to go to instances. And now, once I choose that instance, that QL created RDS instance in the list of instances, it will expand the panel with more information about my instance. But you'll see 3 tabs over here. So some of the monitoring, you'll have some configuration details for the instance on the second tab, as well as some other additional replication details if applicable.
What we need is right at the top here where it says endpoint. So this is essentially the DNS endpoint for your RDS instance. So I'm going to copy that value. I'm going to switch over back to my RDS environment. And I'm going to connect to that RDS instance using that DNS endpoint. Now, the DNS endpoint, whenever you paste that value, will actually also paste the port number. So something you want to do is make sure that this port number here, 1433 : isn't pasted into the server name dropdown. I'm going to switch over to SQL Server authentication. I'm going to log in using the username and password we configured earlier, student, and then pass.123. And I'm going to hit connect. So at this point, SQL Server Management Studio will simply attempt to connect to that RDS instance that we have running. All right, so we've launched and we've connected to the RDS instance. You'll see it here at the bottom. I'm going to just consolidate the local host instance that we're still connected to. And we'll see a couple of default databases available. All right, so we are connected at this point to the RDS instance. It looks no different from here than the local host, the instance that's running on our local host. So we continue our lab. And the next step here in our lab guide will be to import the data, to export the AdventureWorks data out of our local instance and import it into our Amazon RDS instance. So we're going to use the SQL Server import and export wizard on the local instance. We'll leverage the SQL Server native client and connect the two databases. Connect to the two databases and simply move the data over. Going back to SQL Server Management Studio, I'm going to go to databases here on my local instance. Right-click on AdventureWorks. And wait for the menu to pop up. And under tasks, I will click export data. So the SQL Server import and export wizard loads. We're going to click next. We'll wait for the list of data sources to populate. All right. Looks like this, it takes a little bit of time to index the list of data sources available on this Windows instance. So I can click the drop down, and the option we want is really at the bottom of this list. It's SQL Server Native Client 11. We'll use Windows authentication for the list, for the authentication method for the local server, and we'll pick the AdventureWorks database. We'll click next and configure the data destination. All right, and similarly, we'll pick SQL Server Native Client for the destination as well. We'll use the same server name that we used for connecting SQL Server Management Studio. In my case, I still have it in my clipboard. I'm just going to paste and again remove the port number from that connection string. I'm going to use SQL Server Authentication this time. with the name student and the password that we set up. And before we actually do this, which I forgot to do, I missed actually one step, I have to actually create the sample database. So I'm going to go back to our RDS instance and right-click and create a new database. Now, while the options and the configurations are loading, we can go ahead and answer a few more questions. All right, so we create a new database. We'll name it sample. We'll accept all the defaults and click OK. So Ben is asking whether there is any downtime necessary to grow the capacity of the RDS instance. So right now, RDS, you cannot change the size, the storage size of the RDS instance. So what you provision initially, you cannot change that later. Now, unlike in EC2, wherever you can change the sizes of the volumes. Now, if you're in terms of capacity, you're referring to the CPU and memory of the instance. A reboot would be necessary to change the DB instance class of your RDS instance. So yes, there will be some amount of downtime necessary to change compute capabilities of your RDS instance, but you are not able currently to change the storage capabilities of the instance after the fact. Going back to our SQL Server import and export wizard in the lab, I've configured the username and the password, and I can now use sample as the database available for that instance. Oops, this looks like I've mistyped. And there is a sample database that I picked. I click next. And then this option is we want to copy the data from one or more table and view. So we'll pick the top option. I realize the screen hasn't refreshed yet, so just bear with me a second here. Perfect. There's an option here with two toggles. We'll pick the first one, copy data from one or more tables and views. I'm going to click next again here, and it will present me with a list of options of what tables and views I want to move over to the RDS instance or copy over to the RDS instance. And there's a tiny little drop down really at the top right corner of that table that will select all of them. I don't need to make any other changes to this screen, so I'm going to click next. And I'm going to choose the option to run immediately. And at this point, I can just simply click finish, and I have to actually click finish twice, and wait for the wizard to actually complete and load my data to the other instance. All right, and that's it. My data has been migrated from the local instance to the RDS instance. I can close this wizard. And I can go back to my SQL Server Management Studio script view, and I can expand sample, and I can see the tables loaded on the other side. And just to make sure that all the data got loaded correctly, I'm going to go back to my guide, and I have a query here at step 67 that simply selects all the addresses out of our sales LT table, just to make sure that all the data got loaded correctly. I'm going to go back to SQL Server Management Studio. I'm going to hit New Query. And paste that query over. And then hit Execute. And I see all the addresses in our database. Now, this concludes our lab. Just to kind of go a little bit over what we've done today in the lab, is we've set up an RDS database instance. We've downloaded a demo database from Microsoft's website onto a local workstation environment. We've imported that database into a local instance of SQL Server. And then we've used SQL Server import and export to simply move that data from that local instance of SQL Server over to the RDS instance. Now, this is certainly not the only way you can move data and migrate and move data between RDS and other sources or destinations. We also have a service called the Database Migration Service that is designed to both do bulk loads of data as well as apply to do change data capture and apply any changes to facilitate minimal downtime migrations to RDS SQL Server. So you can potentially use also database migration service as well as other third-party tools and marketplace tools to move data between SQL Server running on RDS and either other sources or other destinations. This concludes our lab, like I mentioned. So the only thing left that I have to do is, now that I finished my lab, is I can go in and actually stop the lab. When I stop the lab, you'll be asked to rate the lab by Quick Labs, and you'll still have access to the walkthrough, but the environment will start to be decommissioned behind the scenes, and all the resources that you created will be terminated by the lab provider. This is it. So next, we'll spend a couple of minutes. We have a few minutes left, and we'll spend a couple of minutes answering some of the questions that have been asked throughout this webinar.